Hello student, this experiment is from thermochemistry. We know the thermochemistry is the branch of science deals with thermal changes accompanying the chemical reaction or physical transformation. So for this experiment, we are going to dealing with thermochemistry. That means we are going to find out delta H, that is change in enthalpy, delta S, change in entropy, and delta G, that is free energy, change in free energy. So just start the experiment. So aim of the experiment is to determine delta H and delta S for the following chemical reaction, and the reaction is Zn solid plus copper sulfate gives ZnSO4 plus copper. So for this reaction we have to find out delta H and delta S. So for this experiment apparatus required, so it's required 1/10 thermometer. So why 1/10? Because we have to find out the temperature of this solution is up to 0.1, 0.2, 0.3 degree, like that one. So if you want to see the room temperature, so room temperature of this room is now 24.6 degrees Celsius. So that's why we are going to use 1/10 thermometer. Then as a flask we are going to use here polythene bottle. We are going to use a beaker. Then for measurement of the solution we are going to use a measuring cylinder, and it's required a gas, okay, to heat the water and the balance. Now we are going to start the experiment here. So this experiment is in two parts. First one, we have to find out the water equivalence of the body. Body means water equivalence of this polythene bottle. So meaning of water equivalence means the amount of water which is required, okay, to which is going to absorb or emit the heat which is same as some body. We are going to if we are going to change the temperature of the system by 1 degree, okay, when we are going to change the temperature of the system by 1 degree, so how much amount of heat is going to change, that we are going to find out for this particular bottle. So first we are going to start this one. So what we have to do, first one, take 100 ml cold water, okay. So here 100 ml cold distilled water is there. So for this 100 ml cold distilled water, we are going to measure the temperature of this 100 ml cold distilled water, and the temperature of this 100 ml cold distilled water is 24.6 degrees Celsius. Okay, so sorry, 24.6 degrees Celsius. So that's I am going to write here. (24.6 degrees Celsius). Now the next part of this experiment is heat. Take another 100 ml distilled water in a beaker, heat it. So we have to heat that distilled water up to around 30 degrees Celsius, more than the temperature of the water becomes 30 degrees Celsius more than that of the room temperature. Okay, so already that one is heated. Now we have to measure the temperature of this hot water. Now this temperature we are going to see here. The temperature becomes 63.3 degrees Celsius. So as soon as you measure the temperature, then immediately you have to transfer that water, the hot water, into the cold water. Okay, so our T2 here is 63.3 degrees Celsius. When we are going to mix it, then stir this solution and wait for some time. So what will happen, we have initially the cold water, we added the hot water. Now the temperature of the system is going to decrease. So you have to wait for some time, so temperature is going to decreases. At particular temperature it remains for a small time, means for 2 to 3 minutes, then that temperature we have to measure here. Now see here, temperature is going to decreases, okay, up to 46 degrees is there. Now wait for some times, just check how much temperature where it remains constant for some times. Then we have to mention that temperature as a T31. Okay, so this temperature now here 41.2 degrees Celsius, it remains constant for a long time, so that we have to write here. So 41.2 degrees Celsius. So this is the experimental part for determination of water equivalence. Okay, so using these three temperature, these three reading, we are going to find out the water of equivalence based on whatever the calculation we are going to provide you. Then after this one, the main experimental part, that is the part B, we are going to deal with, and that part is the determination of change in enthalpy, that is delta H, change in entropy, that is the delta S, okay, for the reaction. So whatever the reaction we are going to deal with, so that for that reaction we have to find out the delta H. Okay, so for this one what we have to do, take 25 ml of 0.05 molar copper sulfate solution in same polythene bottle. Okay, then we have to measure the temperature of this system, that is the initial temperature of copper sulfate solution, and this initial temperature we are going to mention as a T4, and that, see here, we got 24.3 degrees Celsius. So that is the T4, 24.3 degrees Celsius. Okay, then for this reaction what we have to do, we are going to weigh 1 gram of Zn powder, zinc solid powder is there, and transfer this powder into the copper sulfate solution. So we are going to use the same polythene bottle for which we measure the water equivalence. Okay, so just transfer it, then shake this one. So now the reaction is going to start. So after starting the reaction, what will happen, this reaction is exothermic reaction. So because of that, the temperature of the system is going to increase. Now initially the temperature of the copper sulfate solution was 24.3 degrees Celsius. Now shake this solution so that the reaction becomes going to completion one. So wait for some time. So what will happen, the temperature is going to increase. So wait for some time, it will go increases, and after some time what will happen, it will go to a particular higher temperature, and that after that temperature again it will start to fall down. Okay, so we have to write that highest temperature. Now the temperature is 25 degrees Celsius is there. Now it's going to increases. Okay, so 26 temperature is there. Okay, so 26.1, 26.2. Now see, the temperature is 26.4 is there. Okay, so it's not now going to increases, it's stop there. Okay, it's constant now. Okay, now it start decreases. Okay, so the highest temperature we have to write as a T5 degrees Celsius, and that temperature here becomes the 26.4 degrees Celsius. So 26.4 degrees Celsius as a T5. Then see here, we have to find out the delta T in observation table. So we know T4 and T5. So delta T becomes now 2.1 degrees Celsius. 2.1 degrees Celsius. So that's it about the experimental part. Now using this using this reading, we have to find out delta H and delta S as per calculation. Okay, so that part is going to provided to you. So based on this reading, you have to find out delta H, delta S, delta G already there with the help of calculation. So this is your work. Based on this reading, you have to find out that results. Okay, thank you.